Okay, let's get started. We'll have a 20 to 30 minute presentation with 10 to 15 minutes of Q&A. Today's presenter is Daniel Liu. Daniel is the Business Development Manager for the Embedded Computing Group here at Moxa. And with that, I'll hand it over to Daniel.
Thank you, Marty. Thanks, everyone. My name is Daniel Liu. I'm the Business Development Manager here at Moxa for the Industrial Computing Group. Thanks for joining us on the topic to talk about the industrial IoT in remote asset management. So here's the agenda. First, we want to talk about what's the goal of remote asset management, and I will use RAM as the acronym for the entire time throughout the presentation for remote asset management. And secondly, we will be talking about the evolution of remote asset management and industrial IoT. The third is what will be the key to build a successful remote asset management systems, followed out with the summary and Q&A later. So before I start my presentation, I would like to start with a quick poll to quickly understand what is our audience background, so I can try to address the applications to the topics. So let's pause for 1 minute, so you guys will have time to click through, what will be your major industry and applications for industrial IoT. All right, so here is the result. We got 53% of our attendees voted. It seems like most of our audience are falling into water, wastewater, power, and oil and gas. That's pretty much expected as we, as Moxa's database, most of our customers are falling into these three categories. So I will try to use those vertical markets as we roll in the presentation and try to highlight that. So first, what is the goal of remote asset management specifically? Remote asset management is not a new topic in the industry, and most of the people, they want to establish this type of system for a few reasons. The first one is, of course, driving up productivity. The longer your products your system stay up, the more productivity that you're gonna get out of the system. That's the basic concept, right? Of course, also driving down cost, because if you have your systems up and running at the entire time without any troubles, it is possible that you have to do some preventive maintenance on your systems. So your overall cost on the maintenance and as well as on the downtime will be driving down. Another note, the latest trend in the remote asset management is to include the video surveillance into the systems, where you can enhance your security. This happens primarily in the power industry as well as the oil and gas industry, where security is the major concern for their facilities, right? So as you can see here in the diagram, Moxa as a networking company, as well as for the data acquisition and the video surveillance providers, we are able to provide a comprehensive solution from the computing to networking and the video surveillance and data acquisition to meet the customers' demands to increase the productivity, to reduce the downtime, and as well as driving down cost. Let's spend a little bit more time talking about what is Internet of Things. This Internet of Things term has been widely used in many places and sometimes being abused. When we are talking about Internet of Things, we are simply talking about networking everything, right? From your washing machines to your dryers to your refrigerators, because the internet infrastructure is out there, so there are a lot of people trying to attach their devices into the network. That's how this Internet of Things start to come up. But when we try to apply this Internet of Things into the vertical market that we identify, like oil and gas, telecom, water and wastewater, what does that mean specifically to us, right? So we come up with this term industrial IoT, or industrial machine to machine. So in the past, the IoT was, again, is not a new concept. In the past, we call it industrial machine to machine. But what is the driving force that actually moved the industrial machine to machine to become industrial IoT? That's the major topic we want to address here in the presentation. But before we touch base on that, I want to spend a little bit more time to re-emphasize the key difference between the industrial IoT and the regular IoT. The industrial IoT requires a very, very high knowledge in industrial application, especially on the equipments that is being networked. Right, we have PLCs, we have RTUs, data loggers, we have specialized equipments out there talking field buses like Profibus, Ethernet IP, things like that. So networking those industrial equipments normally will incur a higher challenges to our users because industrial internet. The internet, the term itself is standing from the IT environment. How can we marry the IT ideas of networking with the traditional automation languages like the Ethernet IP and Profinet? That's the common challenge that we see in the industrial Internet of Things, right? So when we start the M2M systems in the past, most of the systems is being built up like this. M2M, again, is not a new concept. In the past, people are using long-haul radios, or you using serial bus, using different kind of wireless communication technology, but primarily serial-based communication protocols. What they have to do is they have to establish layers of data acquisition layers, like from the remote I/O in the field. They need to have a slave terminal unit collecting all those data, store that in the slave terminal unit, waiting the master terminal unit to pull it, and the master terminal unit will again relay that data back to the SCADA systems at the backhaul. So as you can see, if you have a very, very large remote asset management systems, normally you will have to divide your system into like sub systems, and those subsystems will require multiple layers of data acquisition systems in your system in order to have a successful remote data acquisition systems in place. So the problem with this type of system is that if one node goes down, you have to go through the entire system trying to find out where the problem is actually located. And it is because all the I/O sitting in the field have so many different protocols. You also have to set up a very large protocol conversion servers in the backend, trying to get all those data into your backend SCADA. So what happened now is we start to see people starting to do the migration to use the internet, the ready-to-run infrastructure out there. So you will see the diagrams start to get simpler. People are using a 4G LTE router or 3G routers, trying to connect that to your local data loggers, RTUs, or even protocol gateways. That's pretty common, and that does not play against our knowledge of how to convert the data into a SCADA system. However, because there are more and more people using database and web-based systems, so the challenge now comes up as to how do you bridge the data loggers or RTUs or the PLCs languages or data through that 4G or 3G routers into a database. The challenge that we see in a remote data acquisition systems like this can be summarized in threefold. The first one is how do you convert the front-end device protocols? The second is since those data logger and RTU and POC are being created, decades ago, they do not have the programmability and flexibility allowing you to do some data tweaks in order to feed the data seamlessly into a database. How do you overcome that is becoming a problem. Secondly, the third one will be the IT database is incompatible with the local database where field buses are being used. And converting those protocols will sometimes means you have to spend big money for system integrators, or you have to hire software engineers that understand both the database language as well as the field bus language in order to make that conversion. Building up a system like this can be very expensive. What happened during the course of the past 5 years is that we start to see there is a driving force out there that is pushing the industrial M2M to become industrial IoT. The difference between M2M and IoT, again, is that M2M, people are using traditional radio and serial and field bus communications trying to get the data back to the central locations. But the IoT is trying to use the existing IP-based infrastructures, no matter it's a lease line or a Wi-Fi network or 4G LTE network to the central location where the data are being concentrated. Three major forces and trends in the market where we see is driving the M2M to become industrial IoT. The first one is, again, serial field bus is becoming IP-based. Right, and we also see that there's a convergence of field buses out there too. For example, in the past, all the POC manufacturers, they have their own protocols, right? Like Profibus, CC Link, those type of POC protocols. Now, because everything is start to migrate to IP-based, now you can only see a majority of major three Ethernet-based protocols like Ethernet IP, Profinet, and Modbus TCP. Those three combined it contributes more than 75% of the right. Second, we also start to see the protocol itself becoming more and more open and more lightweight. People in the past, all those protocols, field bus protocols, they are closed system, meaning, if you are not the manufacturer, you cannot acquire the protocol. But now, by joining Profinet foundations or, ODVA for Ethernet IP, you can acquire those protocols at ease with no problem. Also, we see that Verizon, for example, and AT&T, for example, they are also focusing on the M2M market more IoT market more and more. So they are trying to build up their network infrastructure available for the user to use. The third node will be, for the IP-based networking. You will start to see the bandwidth is getting bigger and bigger, and the cost is getting lower and lower. So that's the driving force that we witnessed over the past 5 years. On the communication technology advancement that is actually driving the IoT. The second pillar of the force that is driving industrial IoT is the migration from a closed control system like POC and data logger to a PC. I probably don't have to tell you, what's going on in the school, but most of the students that is graduated from the school right now, they are being trained on PC. a very, very small portion is being trained on the traditional automation like the IEC 61131-3 programming language. The reason is being that, everybody has a PC now. All the smart devices out there are using an embedded system. So because there's a pretty big community and users out there trying to use the PC as the platform, we start to see, people are trying to apply PC to the traditional end-to-end applications. And this will also have a huge impact on the IoT, which I will address later on. The third pillar of the that is driving the industrial IoT is the IT technology advancement. We also start to see there's a closed systems being pushed toward more open systems. In the past, automation systems, they can only use SCADA, expensive SCADA, but now there are a lot of software firms out there. They are doing dashboards and database minings in various different kind of vertical markets like solar power or water, wastewater, creating the monitoring web interfaces for different users. And this, I consider that as an open system because you no more have to spend a lot of money on a closed SCADA. You don't need that high expertise in field buses in order to get your system up and running. All the data is being stored in a database where you can hire different software house to do the database data mining for your application use, right? So, in a very quick summary, the advancement in technology, communication technology, the advancement in IT technology, the prevalence of the PC usage are the three major forces that is driving the industrial Internet of Things. Another trend that we see also has a huge impact in the industrial IoT is the advancement of wireless technology, to be very specific. In the past, you will use radio, you will have to use microwave, you have to use satellite for your remote equipment's data acquisition. You have to buy the radio and set up the tower by yourself. Put the antenna in the right directions so you can relay the data back to the central location. I still remember 5 years ago when I start to market the idea of using the cellular technologies in North America for water and wastewater industry. A lot of people are still resisting to the concept that the cellular technology is actually very handy for the remote data acquisition system they are trying to build. One of the reasons being that first, people do not know, they are not familiar with the cellular network. They are not familiar with IP-based networking. IP is simply aliens word being preached to the traditional automation customers or users. But 5 years after I first trying to sell or market the cellular applications, I start to see there's a tremendous force out there is driving the migration from the serial-based wireless to an IP-based wireless, especially for the cellular applications. The key difference between these two, of course, is that first, the radio and satellite, it has to do with long-range communication, but it cannot service a full-range communication applications. If you have one isolated location where you want to deploy the data acquisition systems, normally you have to buy a radio and put it there in order to have the coverage, right? But now, because the cell tower is everywhere, you no longer have to spend your efforts on putting up infrastructure for it. So the cellular network is considered a very, very big driving force behind the industrial IoT because of the readily availability of it, and in the past the cost is high, now is relatively low. I can also give you some numbers too regarding the growth of cellular network for M2M in North America for your reference. Statistically, in 2013, AT&T and Verizon alone, those two carriers, they have active connections for end-to-end up to 25 million connections. And we expect this trend to continue to grow over the course of next 5 years at the compound annual growth rate of 32.5%. This means that there are more and more people in vertical market we just highlighted will be readily ready and trying to adopt the cellular communication for their applications. In this webinar, we also want to trying to tackle or address, what will be the best practice to use those readily available network for your remote asset management systems. So at a simple note, as you can see now, here is the summary of what I see commonly for remote data acquisition systems. People are using a 4G LTE or a 3G network for long-haul communication, but sometimes people will also use AO211 wireless networking to fulfill the last mile. In the past, people are trying to debate about, whether we should have the last mile using the Wi-Fi and, using this cellular as long-haul communication. Now we start to see there's a merge of those two networks. People no longer wants to use the last mile Wi-Fi because the cellular network is becoming bigger and bigger, the coverage is higher and higher, and the bandwidth is also almost exceeding the AO211 network. Why we wanted to set up this AO211 wireless network if we have a cellular coverage that can cover all? Unless in your data acquisition system or remote asset management systems, there is a place where the coverage for the cellular is not available. Normally, people will be using primarily, cellular to the central location link, just trying to use that AO211 network as the last mile to bridge the gap that is not covered by the cellular network. So before we proceed to what will be the best practice for your remote asset management system, I want to again pause for 1 minute to put up another poll questions. Can you let me know what kind of edge control or data recording devices that you are using for your remote asset management, so I can try to address that more effectively in the following presentation. There are 4 different types as I identify majorly in the application, primarily POC, RTU, data logger. People start to use industrial computers. If none of this is listed, please click none of the above. All right, so here's a simple poll. As you can see, most of our users still now using programmable logic controller and remote terminal unit. This does not surprise me because a lot of our water and wastewater and oil and gas systems are legacy systems. So despite the industrial computer is growing, faster and faster, but the POC and RTU are still the majority of the usage. So now I want to address a little bit what's the difference between using the POC, RTU, and data logger than using the open platform. First, the POC, RTU, and data logger, they normally come with the proprietary industrial protocols like Modbus, Modbus is not considered proprietary anyway. Profinet, Ethernet IP, sometimes, DF1, very special protocols. Whereas if you compare that with the risk-based computing platforms, an open source IT protocols is available as always on the database. When I say IT protocols, I'm referring more to, for example, the SMP, the simple network management protocols, things like that. On the OS side, those RTU and the POC, they have a proprietary OS and a proprietary programming logics. Despite the 61131 is the primary language that's being used on RTU and POC, but different vendors will have different way of programming it, and it requires a few days of training before you can actually start up the programming. Not to mention you still have to get used to it, right? But if you compare that with the computer platform, the OS is almost standard, right? We have Windows, we have Linux as the standard operating system. The programming languages are also standard, and it's being trained in the school, like the C and C++, .NET, Python. Those are the standard language that you can use and choose to use on the risk-based computing platform. Comparing the backend systems between the POC, RTU, and the computer, the RTU and POC, they are meant for the SCADA-based systems, whereas all those computers, they have a generic local database that can easily mirror to your centralized IT database using the standard database protocols. So if you compare this to, most of the people, they'll be using SCADA most of the time on the RTU and POC, but for the for risk computer platforms, you will be more accommodated to the database usage. If you compare the computing power, again, now we start to see a small computer, a box computer that can come with 1 gigahertz or even 1.4 gigahertz computing power. But the RTU and POC, because they are being built so long ago, and migrating the entire programming code, in their system to a new system will simply means they have to develop everything from scratch. So the computing power on those RTU and POC normally are very, very low. We see, only 100 megahertz or 200 megahertz max in those systems. What does this mean or have an impact to your system will be, it is, you have limited ability to localize your logics or your local control systems, because we are now talking about having more and more data being bring into the controller, right? If you have a high computing power in your local site, that means you can process more data. You can have web interface where you can remotely log into your system and see what's going on site. But with all that, all this is not available on RTU platform simply because the computing power is not high enough, right? The last two will be also very important for the remote data acquisition or monitoring system, is the communication expandability. Most of the POC and RTU probably is one of the exceptions, but we still start to see the limitation on that too. All those platforms, they are again being built a long time ago, so they don't even have Ethernet communication, not to mention to have a wireless communication, expandability. Right, so normally what you have to do is to buy an external modem or wireless communication router in order to enable your RTU or data logger to talk wirelessly to the cell network. On the other side of the spectrum where the computer comes in, computer is a computer. They have a USB port, they have standard mini PCIe slot, they have PCIe communication expandability. That makes it possible that all the communication interfaces that you see on your laptop, you can simply expand that on a box computer without any problem. All the OS that I mentioned, like the Windows and Linux, they will have drivers for various different kind of communication interfaces. If you put that again back to the RTU or POC, the driver is simply not there. So if in the future we have 5G communication capability comes up, very likely you still again have to swap out that external communication router. You're not able to use that, generically on your RTU or POC. But on computer, you can use USB or the standard mini PCIe for that wireless upgrade, right? Last but not least is cost, right? RTU, the cheapest RTU I'm aware of, maybe $900. Data logger, $700, right? POC, if we are talking about a high-end POC, we are talking about a few $1,000s, right? Computers, now you can get a 1 gigahertz computer at $300, and with the 4G LTE cards, probably $500 to $600, and you will have a full-blown computing platforms that you can use for your remote asset management applications, right? So compare all those bullet points where I think is important for remote asset management. It become very obvious that the open computing platforms is gonna be the future trend. All the people is gonna use, trying to avoid using the POC or RTU. So the question now comes in, how can I upgrade my systems, right? So if I already have a legacy POC or RTU in place, how do I get those POC and RTU data using the computing platforms? What's the best practice that you can do to get those data back to the central location? Here's what I think a successful remote asset management system should look like. First, again, a computer platform that is industrial hardened can sit in the front end. These computer platforms will perform a few roles. The first one is the computer needs to have a built-in industrial protocol for edge connectivities to talk to the PLC, to the RTU using, for example, Modbus TCP and RTU. Back to the very first slide that I show, the biggest gap right now between the traditional RTU and PLC user and the new computer user is that computer users, they know computers. They know computer IT-based protocols like SMP. Modbus TCP is a totally different language in their world, right? So if you have a computer, that does not mean you will be able to implement a successful automation system, because you don't have that ability to get the field bus protocol into the computer platform, where the computer platform can convert the data into a database and then synchronize the data with the backend database. So optimal computer platforms for remote asset management, especially for the automation application like water and wastewater and oil and gas. The first criteria will be having the computer able to talk industrial protocols, right? The second one is gonna be the easy store and forward API and GUIs. Again, if we only provide an open platform without a tool allowing the IT people who know C and C++ or .NET to acquire the data from the POC. There's no way that you can do the system migration from legacy to a more advanced PC-based data acquisition system. So the computer platform needs to have an API or even GUI allowing the customer to set up the Modbus TCP or Modbus RTU communications between the POC RTU and the computer itself. Third very important point to do the migration will be the computer itself needs to have a wireless communication optimized for long-haul communications. Moxa, for example, we have products that can have Wi-Fi inside, can have 4G LTE inside, but having all those communication boards inside the computer does not mean you will have a successful long-haul communication because there are simply too many bits and bytes you have to pay attention to when you want to have a successful 4G LTE connectivity. For example, how to keep the network always alive. How do you set up the VPN network with that? All this you will have to rely on experts that have optimized platforms to implement it. Right. Again, the third one, the last but not the least, will be the how to synchronize the local database with the remote database. If you have a tool that can synchronize over this, then it's much easier for you to map all the data that you acquire from the POC back to the central database. So in a summary and review, to enable a remote asset management network for industrial IoT, we think cellular network, especially 4G LTE, is going to be the future trend because the infrastructure is readily available. It's much easier to implement. The second important message I want to present to you in this webinar is the industrial PC in IoT is going to be the major force driving industrial IoT in the oil and gas, water, wastewater, and power industry because the cost is lower, the entry barriers is lower, and it allows a seamless connectivity with the IT database. All right, that's the last slide of my presentation. I hope everybody will benefit from it. Before we end the session, I want to get into the Q&A session. So in case during my presentation you have any questions, now's the right time to raise your questions.
Great. Thank you so much, Daniel. Tons of great information there. Hopefully most, if not all of you guys and gals will be able to utilize this in your day-to-day roles. Daniel, we do have a couple questions in here. The first from Andrew. Andrew asks, in your presentation, you mentioned there are open source codes available. He wants to know where you can get information on those resources.
Sure. The open source nowadays are more readily available in the past because if you are familiar with Linux platform, most of the new platforms come with the Debian system or Ubuntu system inside. In Debian, for example, there are multiple mirror servers around the world. And those mirror servers, they maintain a huge database for ready to run, open source applications on it, right? So you can easily find the local mirror server and use a simple apt-get command. Once your device, as long as your device is connected to the internet, you can use the apt-get to get all those open and free resources out of it. If you are interested in the detail of how to get those data, please give me an email. You can see my contact information on the screen. I can send you more information on that. Just give you a few examples. For example, if you want to enable the computer to become an Ethernet to cellular router at the same time doing data logging, there are some ready-to-run application that allows you to build up a VPN, do the data logging, put all those CSV file into a FTP server at zero cost, right? All you need to do is just to find a local mirror server and just synchronize with it, and you'll be able to get the data out of it.
Great, thank you again, Daniel. I have another question here from Carl. His question: in a computer-centric versus PLC-centric architecture, he wants to know if there's a role for industrial Ethernet or maybe even OPC. So maybe share your thoughts in regards to his question.
Sure. Industrial Ethernet, if you are talking about wired network, of course, that's what I call the last mile. People will set up a local LAN network, and then they will have a computer at the very end of the network trying to collect all the data from that LAN network. And they can use either Wi-Fi or any Ethernet protocols trying to send the data to a centralized PC, where the centralized PC is playing a role of collecting all the field data into that concentrator, and then use that as a database to synchronize with the backend database. Very simple answer to your question. Yes, there's a role for industrial Ethernet, that's for sure. But for OPC, my understanding is that OPC in the past were a platform that tried to offload the SCADA loading. But I start to see a less role for OPC in this type of system because it is becoming a bottleneck. All the computer platform now has so much computing power, they do not rely on a separate server to offload their processing power. Secondly, as I mentioned in my presentation, there's a convergence of field bus protocol nowadays. You can see Mitsubishi, for example, Omron PLC now, that using Ethernet IP, where it's very difficult to imagine in the past because people will think Ethernet IP is more of an Allen Bradley kind of thing. But now you will see there's a convergence of field bus protocols. So the OPC's role in the past was trying to collect all different type of field buses into one simple tunnel and feed that into a SCADA system. Now that does not exist anymore. So I see more and more people are using SCADA, if they are using SCADA at all, trying to use that direct connection using field bus protocols talking to the POC systems. So the answer to you is I do not see a role for OPC.
Great, thank you again, Daniel. The next question / comment I have is from Bruce. He's asking, he wants to know in regards to M2M cellular plans, how much does VPN add to traffic overhead on these types of connections? So maybe if you have any insight there, feel free to share it, Daniel.
Sure. This is actually a very good question because people does not want to pay the overcharge on data, and cellular still in M2M consider still if you have 1,000 nodes out there, the price can be high, right? So the less data you're gonna use, the better. VPN, there are actually two different methods to implement VPN. The first one is you just establish the VPN tunnels by yourself, and then connect that with the central routers where you have the VPN services, right? The overhead will be entirely on your own because you establish the data, the tunnel, the data flowing through it is encrypted. You are liable for that. But there's another services coming from the carrier where they call the mobile VPN services. They sell it as a package actually. This way you do not have to set up a VPN server at your location. The carrier is responsible for it, right? And this way they do not charge you for that VPN overhead. But the bottom line for the VPN is that there are multiple different protocols that you can set up the data encryptions. If you are using IPsec, which is more heavy, then the overhead is going to be higher. It also depends on what kind of data you are trying to encrypt it. If you are using OpenVPN, it's lighter. But there's also another way. If you do not want to set up a VPN, just want to have your data encrypted, then there are some lightweight SSL encryption engines that is available on the computing platforms where you can use too. That you can also reduce the data overhead with it.
Great, thank you very much again, Daniel. The last question I have is from Sergio. And he's asking, in regards to SCADA and RTU protocols, and by SCADA protocols, he's talking about DMP3, IEC 61850, also Modbus. In regard to these protocols, he's saying that they're there for a reason and maybe fit a certain type of operation or setting. And also, he references the fact that you mentioned or talked about PC protocols, SNMP and others. But, PC users have been using OPC for quite a long time to bridge these protocols. Can you comment further on kind of like his question and comment in regards to the protocols and how they all play together?
Sure, that's a very good question too. DMP3, IEC 104, IEC 101, those are very common end-to-end protocol in the past. Those protocols are being created to accommodate the low bandwidth and the distributed serial-based network I just mentioned using radio and satellite. Again, to me, those protocols are specialized for special vertical markets, for example, like power industry. They want the sequence of event where 1 millisecond accuracy and the time synchronization is absolutely essential for the power industry. But in water and wastewater industry, for example, in the past, they use DMP3 because DMP3 is lightweight and is an active protocols where they can have the active alarm coming from the field. They do not need all the function that is designed for power on DMP3, for example. In this regard, I'm saying DMP3 might not be replaceable for a period of time because in power industry, they need those special function inside the protocol itself. But in water and wastewater industry, for example, they do not need it. As a matter of fact, in Australia, for example, where they used to use DMP3 in the past, they discovered DMP3 is creating cost overhead because you need to have engineers that specialize in DMP3. You need very, very expensive RTU that can talk DMP3 slave and master. The programming effort is also very high. And not to mention the engineer that specialize in all this is very difficult to find nowadays because all the students are being trained on PC platforms. So there is actually a very strong driving force in Australia, for example, trying to drive the water and wastewater monitoring system away from DMP3 to use SMP. And SMP obviously has a few advantages. It's lightweight, it's open, it's free, and all the students graduate from the computer school, they know how to use it. So with that, I think DMP3 and the IEC 104 is not going to be gone in a short period of time. That's why I still think there will be a need for industrial gateways where they have to convert all those industrial protocols into lightweight ITE-based protocols. As a matter of fact, people can also use computer for that role too. But I would say as time grows and as PC become more and more prevalent, those protocols usage will be reduced over time, and the IT-based protocols will be used. It will be growing, over time, especially for the long-haul communication. For OPC, I just made my comment. I think OPC has already become obsolete. That's why they come up with the OPC UA, so they can act like a field bus. But their primary goal in the past is to concentrate the data to feed that into the SCADA. I just don't see that will be the major playground for them anymore, because all those field bus is conversion into one or two only.
Great, thank you. Thank you so much, Daniel, for your time and for your insight. And thank you to everyone for your interest and participation. Thanks again for tuning in, everyone. Have a great rest of the week.